This reaction is not possible to prepare unsymmetrical alkanes with good yield. That means, see here, if I want to prepare like pentane, if I want to prepare pentane, then I have to take two different types of alkyl halide. Like if you see here, if I am taking here this compound with this compound, then only you see here is we remove to NaCl. What will happen on here? This is radical and it will become here radical. Correct? Then what will form? This will form. You see, if I am adding this one and this one, okay, if I am adding like this, pentane forming. Correct? So we can prepare what one? Odd number containing alkanes from this reaction, but not with good yield. Not with good yield.
Sir, voice is not audible, sir.
Not audible. 1 minute.
Yes, sir. 10 12 no, sir. Axis box. Yes, sir. Okay, sir.
I will record and delete. No need. Excuse me, sir. Carboxylic acid, direct method. So carboxylic acid, NaOH, CaO, strong leading group that one, RHT is forming. Salt of carboxylic acid, RHT is forming. Direct method. So in this, if you want to prepare methane, we can prepare here. Why I will take CH3CONA, CH3 and H. What will form? CH4 will. Methane we can prepare from this. And any type of alkane we can prepare, no doubt at all. For example, if I want propane, what will take here? Sodium salt of butanoic acid. Why one carbon decreasing? Propane I want to prepare. Butanoic acid you have to take. Sodium salt of butanoic acid. CH3, CH2, CH2, CON. Then CH3, CH2, CH2 combined takes the what will form? Propane will form. Like that. Logic. Now you write here mechanism. How it is forming? First RCON minus Na plus it is forming. That CO minus here double bond. R is going as minus. So carbon ion is forming. Now remember, in this soda reaction, carbon ion is the intermediate. In this carbon ion is the intermediate. Understood? Very important. Why? There will be different acids. Which acid will undergo easily decarboxylation? Like this question they will ask. Then you have to remove total CO. You have to check this carbon ion. That carbon ion is more stable. The corresponding acid will be partly will form soda lime reaction. Partly it will decarboxylation occurs like that. So what is the important thing on here? Carbon ion is formed. Then H plus from this NaOH from water, H plus it is forming actually. From water only it will form actually. H plus. You understand now? Formation of carbon is RDS means rate deterministic step. RDS means rate deterministic step. So rate of decarboxylation directly proportional to stability of carbon ion. For example, see this one. There are different types of carboxylic acid. Now here I am taking this one compound. In this carbon ion is what it will become? Tell me. CH3, CH2 minus will be carbon in this case. In this case, CH3, CH, CH. This is the carbon ion. Understand what I'm telling? Here carbon ion is C minus. Now tell me in these three, which carbon ion is more stable? This one. Why? You know, in the basics, 321 I said. This is for carbocation. Then reverse is carbanion. So answer is this one only more. So this acid easily undergo decarboxylation. So by giving three different types of any acids, they lost which are carboxylic acid fastly after decarboxylation. Then we have to remove and make carbanion. And by using the inductive effect, mesomeric effect, resonance effect, everything, that one we should know which carbanion is most stable. Then we will tell like this. Okay, understood how the question is asked. Okay, so these are the important points you have to remember, and it is used to prepare any type of alkane. For example, see, I want to prepare this alkane. Which type of sodium carboxylic acid I have to take? I want to prepare this alkane from soda lime. What is the acid of sodium salt of acid? I said already. For example, I want to prepare CH4, one hydrogen removed, remaining CH3 you take, attach CON. Then this is responsible to prepare. Like that here, you see. Important. Anything you can take actually, you see. Here CH3 is there now. From that one hydrogen removed, CON. Yes, can we prepare or not? We can prepare. Even you see. Another thing. Same compound. Here CH2 is there now. CH2. One hydrogen I will remove. CONA. Yes, it is also found. Here also hydrogen is there now. If hydrogen I am removed, CONA. Yes. Here also CH3 is there now. Then here also CH2 CONA. But this one same. So how many types of carboxylic acid we can use to prepare that compound? 1, 2, 3, 4. Like this question they will ask. What am I really? See, I want to prepare this compound. If I am taking, you see, in this, one hydrogen I will remove. Total it will remove now. And hydrogen attached now. Then this compound will not form. This is possible. This side one hydrogen will remove CONA possible. One positive. This one, two. This one, CH3. CH3. Here hydrogen is there now. That hydrogen I will remove CONA, I will attach. Huh? What same? Huh? You tell me this one and here CONA same compounds are. Then different acid now. I am asking how many different types of acid we can take to prepare this compound. Understood? Then what is your question? What you are thinking? I think my question not understand. How many types of acid I can use to prepare this compound? Like this question they will ask. How many types they will ask? Which kind ready? One is by using decarbonation, which is easily decarbonation occurs. Like that. Understood? Okay. Now, tell me this one answer. What is the compound? Hmm. Tell me firstly what is the compound? What is the compound? Confusing, you see Nana? COONA, NaOH. What will do? Removed. And what will attach? Hydrogen. Hydrogen attachment, this one only forming. Not understanding. From this, you understood this one? COH means first what will form? NaOH you have to take. What is that NaOH? COONA plus NaOH. From that I will remove Na to CO3. Here carbon removed. 1, 2, 3 carbons only. Here 3 carbons CH2. H is attached. Then what will form? You remember, 1 carbon less alkane will form. That I am telling you. For sodium soda and decarbonization, whatever the acid you take, 1 carbon less it will form. 1 carbon less it will form. See, I have one doubt. 1 carbon less it is forming, I am telling you. That's correct. Correct. You tell me this. What will form? No. What is the name of this one? Decarbonylation is CO2. Remove CO2. Attach hydrogen. It is forming now. Here also what will form? Sir, pH, H, what it is? Benzene. Understood? And for understanding, I am giving you, see here. COONA, NaOH, H attached means what will form? Benzene. Get it out? This C6H5, CON. This carbon I removed. Here what carbon? Upper. Understood? Not on this carbon. This carbon I have no. Understood? Got it now? Now tell me this one what will form. What is the name of the substance? What is the exact name of the substance? Tell me here. What is the exact name of the substance? of substance. And a pH means what? Write this one. What you are doing? H attached. Then what will form? CH? Toluene. Toluene. You know? Simple. Then why are you not telling? This many times I am telling. Remove carbon containing. Attach hydrogen, that's all. Direct method I am telling Nana here. You see direct method. I am telling direct method. What is direct method? What is direct method? Tell me. Remove CO, H attach. That's simple we can get. Now see here. Okay. From alpha let me just right. Next, you write Cole's electrolysis. You write Cole's electrolysis. Cole's electrolysis. Cole's electrolysis. What is this? Electrolysis. We will take sodium salt of carboxylic acid. Mono. Sodium salt of monocarboxylic acid. I will do electrolysis. Normal electrolysis means it will dissociate into cation ions, right? Like it is salt, how to dissociate? Generally, CH3CO minus K plus or CHCO minus Na plus. Water also will dissociate. For example, see here what I am telling. In Cole's electrolysis, they are taking, this is the reaction you see. CH3 CONA plus H2. Electrolysis I am doing. Actually, what will how it will dissociate minus plus? Water also how it will dissociate? Tell me. H plus OH minus. You know minus will go towards anode or cathode. Anode it will go. Plus it will go towards cathode. Then what will happen? This will discharge here. OH will be retained in solution. Na plus H plus, which will discharge here. H plus will discharge, Na will be retained in solution. So in solution, what is retained? Na plus OH minus. So basic solution will become. But now this is what is happening here. They are giving C double bond O minus. But one electron it will give. One electron. Dot it will. Here what is happening? Heterolytic fission will occur. Sorry, heterolytic fission will occur. Then what will form here? What will form? Not here. Here we are not getting. Heterolytic fission. Radical will form. Because Na plus by taking one electron it will go like that. So here radical means CH3 dot. Here CO dot. By combining CO2 will form. CO2 will go. Since the dot it is forming now. Like this, only one dot will not form. There are so many molecules now. Another CH3 dot it will form. That will combine to form alkane. So you have to remember one point in both process. Whatever the acid I am taking, you take that one as CH3X. Like which reaction what will form? Ethane will form. Like this here of ethane. Understand what I am saying? See that mechanism I am giving now. Don't confuse. You see first. What is happening? R dot CO dot R dot is forming. R dot is coming there. This is direct method for understanding. Mechanism I will tell. I will give. I will explain the mechanism. I will explain that fully. R dot CO dot. You take that one. Lock it. Another R dot attached. We can get alkane. Here also, this method is not useful to prepare, unsymmetrical alkanes, like Wood reaction. Why this R dot Again, R dot combine, if this R is two carbons, two carbon, one carbon, one plus one. So we cannot prepare unsymmetrical alkanes. They know that is generally odd number. Odd number content we cannot prepare from this. Why? If you take odd number carbon, another odd number will come. Odd combine to form even. That is the reason. Understood what I am taking? And also we cannot prepare methane. Understood what I am taking? Like Urju reaction. Like Urju reaction. Any doubt? Okay, understood. So like that you see, CH cross is done. Two carbon container, four will form. Like that. Okay, see now. Actually what is formed mechanism you write. Mechanism you write. Here they take potassium salt, no problem. Sodium salt, but monocarbonic acid. What is forming now? RCO minus. From that one electron it is giving, and it is forming radical. From that electrolytic fission, R dot combining, it is forming here. So here main important point is at anode what is forming, at cathode what is forming you should know. At anode alkane will form, carbon dioxide will form. At cathode hydrogen will form. That's why. You write that point out. Important. I will give that all the points here. Same here of steering entrance concept like reaction type only. Understood what is happening here? This is dissociating minus plus. This is dissociating minus plus. 2 moles run. So 2 moles of this one, how it is giving? It is giving 1 electron. By forming 2 electrons, it will, because 2 moles now. If 1 mole, 1 electron, 2 mole, 2 electron. Dot it is formed. That dot in this dot, because here heterolytic homolytic fission, CO dot combining CO2 is going, R dot to R dot combining RR it is forming. And the cathode H plus will go. Now cathode two things will go. K plus will go, H plus will go. Which will discharge first? Hydrogen will go. Understood what I did? Hydrogen will discharge, H2 will form. So K plus remained, OH minus remained, then KOH will be increasing. That means what will happen increases slowly in this reaction. Completed. So what is the important point here? Alkane and carbon dioxide released at anode. H2 released at cathode. Anode, what is happening? Generally, at any anode, oxidation occurs, cathode reduction occurs. That is common. Nature of solution of electrons is basic. The reason is base will increase. Base will be more than 7. Like that. Any doubt? In our series textbook, only 1, 2, 3, 4, 5 reactions. From unstable hydrocarbons, any alkene, alkyne, H2Ni, we can get alkene. From alkyl halide, zinc with HCl, except fluorides, we can get alkene. Alkyl halide. Halide remove hydrogen attached. And from which reaction you know, you understood. Here there are so many questions they will ask. What is the which reaction you understood? Alkyl halide Na, represent high ether. You have to remove halogen, dot, another dot attached. Only it is useful to prepare symmetrical alkenes. It is not possible to prepare methane. Symmetrical alkenes, correlated that standard completely. Like that, from carboxylic acid to things, decarbon soda like directly CO liquid attached. That's all. We can get our alkanes. Okay, so methane is possible. Any type of alkane we can get. And whereas in this third, that whole cell process, like reaction, like COA removing dot, imagine dot attached. We can get alkane. Same thing. Understood, but you have to remember at anode what will form, at cathode what will form. At anode carbon dioxide and alkane forming. At cathode only hydrogen forming. In solution, K వచ్చింది or N వచ్చింది remaining. pH is greater than 7, like that. And now, you see, here if you take, tell me what is formed. Important. It is monocarboxylic acid. Remove. Directly what will form? Attach hydrogen. This will form. Remove hydrogen form. Here, it is different. It is not monocarboxylic acid. Dot, it will become double bond. Alkene. It actually is explaining alkene preparation. All the double bond is there now. Like this. This I will tell you alkene preparation. But not given in CG station. Just I am telling you. Now, one thing I want to tell you. If I am taking Wood reaction, here also what we can get, sorry, CH2. Here also double bond CH2 we can. Intra is greater than given in Wood reaction. You can check it. Intra and inter on Wood reaction. Intra is greater than inter. Inter means what you know. This will form. Because you see CH2, Cl, CH2, Cl. If I am taking Na, 2Na, then total if you remove, this is formed. This is inter between two. It is intra within this. That is an intra is major, inter is minor. These are possible to reaction. This much thing they will ask us that means in NEET level they will not ask. They will not ask. Where they are not easy. Understood? So like that one. Got it? See here. Okay, tell me this one. What will come here? You know Ujju reaction? Ujju reaction, you know? This is monocarboxylic acid. Here, keep X, which will form. You see. That. Take U image, what will form? Attach this compound. If I am using soda lime, this will form. For this soda lime, if I am using this will form. Are you getting that? Tell me here what? Simple. Take dot image. This image is this one. Attach. I'm telling every time. What I'm telling you understood. Take a dot image, you take attach. You can get answer. Simple. In CV study, we go into examples into nicely. That's all completed. But questions in this manner you have to do fast. Okay, understand now? But don't confuse. Soda lime, what is the reagent? Whole cell process for electrolysis. Different. Okay. Now, other type of reactions I will give. You write extra points from Grignard reagent. From Grignard reagent. Alkane we can prepare from Grignard reagent. What is Grignard reagent? RMPX, you know. Grignard reagent is alkyl magnesium halide. Alkyl magnesium halide. Grignard reagents are carbon ion generators. Why this is metal, right? You see now, magnesium is metal. Metal will lose electron or gain electron? Lose electron. So it will give electron. So such that R minus will come. So Grignard reagents are carbon ion generators. Then from water which plus it will attach alkane will form simply. The Grignard reagent in water they will not keep generally. Whenever Grignard reagent is coming, ether will keep in the preparation of alcohol like the aldehydes ketone. Ether they will keep Grignard reagent. But if you keep water, directly it will form alkane. Not only with water, all proton donors, RH proton donor, argon and H+, it will form alkane. NH3 proton donor, it will form RH. RCOH proton donor, it will form alkane. Water proton donor, it will form alkane. Any proton donor, the Grignard reagent, alkane will form. The extra point, not period. And this will be useful in further. I will explain chemical property of carbonic acid. Chemical property of alcohol. Understood what I said? Or Grignard reagent reaction. Alkali has a Grignard reagent principle. One compound I said now, Corey house is this one. First what he is getting? Dialkyl copper lithium. This is Gilman reagent. So when Rx, see mechanism they are telling reaction I will do. Right, reaction. Rx, lithium, copper chloride, R dash X, R dash. You write this reaction. Corey house synthesis. Corey house synthesis. What is forming? R2Cu Li. That is Gilman reagent. Lithium, copper chloride. Like that. So why it is useful? It is useful to prepare any type of alkane, whether asymmetrical or symmetrical. Because the combination I will use here. If I want to prepare pentane, here I will take CH3, here I will take 4 carbons. Or here I will take 2 carbons, here I will take 3 carbons. Or here I will take 3 carbons, here I will take 2 carbons. Then my choice. Such that easily what you can get pentane. So that is the reason Corey house synthesis is useful to prepare any type of alkane. Symmetrical or symmetrical or understand? What will form middle? Gilman reagent will form R2CuLi, RX, RLi, CuCl, R2CuL, Gilman reagent. Mechanism they are telling here. Nothing is not needed. We need leather. Okay. So with this preparation completed, after the properties you see in our Series textbook. You know, from aldehyde and ketones also we can prepare. You know the term Clemmensen reduction, Fulkistner reduction. Wherever double bond is there, hydrogen is attached to hydrogen. What is that reagent? Zinc amalgam HCl. Better, right? Clemmensen reduction. Wolff-Kessler reduction. Named reactions I am writing. Any aldehyde or ketone with Clemenson reduction, what will come? Alkane. See, double bond removes H time attached. Wherever double bond H time will attach. Wolff-Kessler reduction NH time KOH. Clemenson reduction, Wolff-Kessler reduction. Again, you study aldehyde and ketone. This reaction. Just remember, any aldehyde, the reagent is important. By seeing reagent and compound, you come to know, okay, this is the name of reaction, Clemenson reduction. By seeing reagent and this one, this reagent don't confuse. This is in the basic medium. In acidic medium, it will become nucleophilic substitution reactions. Nucleophilic addition reactions. Aldehyde ketone, same it will form. Wolff-Kessler reduction. Okay, simple. Wherever ketone also, if you take acetone, propane will. Acetone is CH3, C double bond, double bond will hydrogen. If you use this one or this, like this. So alkene is preparing. So why we cannot keep here as a preparation? That I am telling. I am telling this preparation that it becomes property or chemical property for aldehyde and ketones. This preparation, there it will become chemical property of aldehyde and ketones. Like that. Now tell me this question. The product formed in the reaction is. Now tell me this is alkali halide. This is sodium ether, then it is Wurtz reaction. Tell me what it is. A, B, C, D, what you are thinking? What? D, how? Intra bond will form. Bond will form. This is the answer. D is the answer. Like that. See, this is very different question. Normally, Wurtz reaction is alkali already again removing. Like that is not used. Intra. Tell me this. Which of the following will form cyclohexane of reaction with 2 moles of NaN ether? See, cyclohexane on reaction with 2 moles of NaN ether. I want to get cyclohexane, Nana. I want to get cyclohexane. Which compound you will use to prepare cyclohexane? That is the question. Nana, this is Wurtz reaction only. If I am taking this one, what will form? Cyclohexane will form. What will form? Butane will form. Butane will form. If we take this one, cyclohexane will form. Wurtz reaction means what? Wurtz reaction means. This is Wurtz reaction. So this is not one. If we take this one, that means this is not cyclohexane. Bicyclo. If you take this one, what will form? You tell me. NaCl, NaBr going here too. Is it cyclohexane? How can you? because CH2, 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 CH2. Here CH2, here Cl, here Br and then that will go. So cyclohexane. Ready to come. Intra intramolecular reaction. One cyclobutane will react with 2 moles of Na in ether. First you write that compound is it. Cyclobutane. What the answer? What you are doing? See, one chloro, 3 chloro, between 1, 2, 3, 1 here. So, intra. Easy. Like that questions will be there. General. I talked about the main level question. Already I discussed mean level questions completed. So next properties I will discuss next class. First you prepare within 5 minutes. 5 o'clock what is the exam? Your